Galvanic cell or voltaic cells are the electrochemical cell in which the chemical energy is converted into electrical energy. An element is in contact with own ions. When it is in contact with its own salt solution, then that is called as what? Electrode. Standard reduction potential itself is the standard electrode potential. Electrode potential is denoted by E. Standard electrode potential is denoted by E naught. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to 5th session of chapter Electrochemistry. 5th session of chapter Electrochemistry. In the previous session, that is in the 4th session, I discussed about electrolytic cell and electrolysis. Okay. Second point, the quantitative aspects of electrolysis. Faraday's first law of electrolysis, Faraday's second law of electrolysis. Okay. In the last session, that is in the 4th session, I discussed about electrolytic cell and electrolysis and quantitative aspects of electrolysis, Faraday's first law as well as Faraday's second law. In this session, in the previous session, I discussed about electrolytic cell. In this session, I am going to discuss about electrochemical cell. Electrode potential, standard electrode potential, Daniell cell, symbolic representation of galvanic cell. My dear students, in this session, I am going to discuss about electrochemical cell, electrode potential, standard electrode potential, Daniell cell, symbolic representation of galvanic cell. Symbolic representation of what? Galvanic cell. Now, the first topic is galvanic cell. So, already you know that the cell which is used to convert electrical energy into chemical energy is called as electrolytic cell. Electrochemical cell in which chemical energy is converted into electrical energy. Chemical energy is converted into electrical energy. Such cell is called as galvanic cell or voltaic cell. Galvanic cell or voltaic cell. Alige, what are galvanic cell or voltaic cell? Galvanic cell or voltaic cells are the electrochemical cell in which the chemical energy is converted into electrical energy. Chemical energy is converted into electrical energy by using one electrochemical cell, that is called as galvanic cell or voltaic cell. Galvanic cell or what? Voltaic cell. Galvanic cell or what? Voltaic cell. Okay. Chemical energy is converted into what? Electrical energy. Okay. So, before studying in depth of this voltaic cell, you have to know about one term, that is electromotive force or EMF. Electromotive force or EMF. Electromotive force or EMF is defined as, it is the potential difference between two electrodes. One is anode, another one is cathode. When no current is drawn from the cell, when there is no current in the circuit, the potential difference between two electrodes is called as electromotive force. Is called as what? Electromotive force. What is electromotive force? Electromotive force is the potential difference between the two electrodes when no current is drawn from the cell. EMF is measured by using potentiometer, and EMF of the cell is equal to formula E cathode minus E anode. E cathode minus E anode. How do you calculate EMF of the cell? EMF of the cell is calculated by using formula E cathode minus E anode. What is E cathode? E cathode is electrode potential of cathode. E anode is electrode potential of anode. Electrode potential of what? Anode. Therefore, my dear students, what is EMF? EMF is the potential difference between two electrodes, potential between two electrodes when no current is drawn from the cell or there is no current in the circuit, EMF is measured using potentiometer, EMF is equal to E cathode minus E anode, Now, what is electrode potential? Before that, you should know about what's the definition for electrode. Electrode is also called as redox couple or half cell. Half cell. What's an electrode? An element it is in contact with its own ions. Element is in contact with its own ions. How can you construct an electrode? Dipping an element in its own salt solution. For example, if you want to construct zinc electrode, you dip zinc in zinc sulfate solution. If you need copper electrode, dip copper rod in copper sulfate solution. If you want silver electrode, dip silver in silver nitrate solution. So, when an element is in contact with its own ions, when it is in contact with its own salt solution, then that is called as what? Electrode. In electrode, already you know that we have two electrodes, anode and cathode. Anode is an electrode where oxidation takes place. Cathode is an electrode where reduction takes place. Now, let us consider electrode potential. Electrode potential is defined as it is a difference in the potential difference between two electrodes when an element is in its own ions in solution at equilibrium. What is electrode potential? Electrode potential is defined as the potential difference between an element and its own ions. Potential difference between an element and its own ions in equilibrium is called as what? Electrode potential. It is denoted by the symbol E and is expressed in volts. Next, the magnitude of the electrode potential depends on the following factors: nature of the electrode, concentration of the ions, temperature and nature of ions in the solution. What is electrode potential, my dear student? It is the potential difference. Between an element and its own ions. Dipping in its own salt solution at equilibrium. Electrode potential is denoted by E. This electrode potential depends on four factors. First one, nature of the electrode. Second one, concentration of the ions. Third one, temperature. Fourth one, nature of ions in the solution. This is about electrode potential. Okay. Standard electrode potential. It is denoted by E0. Standard electrode potential also potential difference between an element and its ions when it is dipped in its own salt solution at equilibrium. But the concentration of the ion must be 1 molar if the partial pressure of the gas if involved is 1 bar as well as temperature is 298. When the concentration is equal to 1 molar, temperature is 298 Kelvin. If it is pressure is 1 bar, that is called as what? Standard electrode potential. It is denoted by E0. Electrode potential and standard electrode potential. is at any temperature, but standard electrode potential is measured at 298 Kelvin, as well as the concentration of the solution is 1 molar, and if it is gas, the partial pressure of the gas should be 1 bar. 1 bar, that is called as what? E0, that is standard electrode potential. According to IUPAC convention, standard reduction potential itself is the standard electrode potential. Standard reduction potential itself is the standard electrode potential. So, the values of standard reduction potential as well as standard oxidation electrode potential numerically same but of opposite sign. That is, SRP is equal to minus SOP. That is, standard reduction potential. Standard reduction potential is equal to minus standard oxidation potential. The values of standard reduction electrode potential and standard oxidation electrode potential are numerically same. They are numerically same but opposite in sign. That is, SRP is equal to minus SOP. SRP is standard reduction potential. SOP is standard oxidation potential. Standard oxidation potential. Okay, so now regarding about galvanic cell or voltaic cell, you require two terms. One is say electrode potential, another one is standard electrode potential. Electrode potential is denoted by E, standard electrode potential is denoted by E0. Okay, now the very good example for voltaic cell or galvanic cell is Daniell cell. Daniell cell. Daniell cell consists of anode as well as what? Cathode. Anode as well as what? Cathode. Anode is zinc rod dipped in zinc sulfate. Zinc rod dipped in zinc sulfate solution. Zinc sulfate solution. Cathode is copper rod. Copper rod is dipped in copper sulfate solution. Copper rod is dipped in copper sulfate solution. A galvanic cell in which the negative electrode means anode. Negative electrode means anode, zinc, and positive electrode is copper, is called as what? Daniell cell. Therefore, Daniell cell is constructed by taking which one as an anode? Zinc electrode. That is, zinc dipped in zinc sulfate act as anode, copper dipped in copper sulfate which act as what? Cathode. Observe in the diagram, zinc electrode, zinc dipped in zinc sulfate, copper electrode, copper dipped in copper sulfate solution. Copper sulfate solution is the diagram of Daniell cell. Daniell cell. Zinc electrode is set by dipping zinc rod in zinc sulfate solution. Copper electrode is set by dipping copper in copper solution, as well as it is connected to, externally connected by copper wire through switch key as well as variable resistance. The two metal rods are connected externally using a conducting wire through a switch key as well as variable resistance, as well as they are internally connected by inverted tube. This inverted tube is called as salt bridge. Salt bridge. Salt bridge is an inverted tube which is filled with K plus and Cl minus ion in agar-agar. Okay, in agar-agar. So, it's a diagram of Daniell cell. Observe, my dear student, zinc rod is dipped in zinc sulfate, copper rod is dipped in copper sulfate. It is externally connected by copper wire through switch key as well as variable resistance. Internally connected by inverted U-tube. Inverted tube is called as salt bridge which containing K plus and Cl minus ion in agar-agar. Okay. So, therefore, see, once again I will read. Zinc electrode is set by dipping zinc rod in zinc sulfate solution. Copper electrode is set by dipping copper rod in copper sulfate solution. The two metal rods are connected. Externally using a conducting wire through a switch key and variable resistance. The two solutions are kept in contact without direct mixing using a porous barrier or a salt bridge. Okay. When the circuit is open, the following half cell equilibria are set up at the two electrodes. Already you know that anode is zinc, anode as well as what? Cathode. At anode, oxidation takes place. Zinc in solid form, it going to lose 2 moles of electron and it get oxidized to Zn2 plus ions. These electrons are taken by Cu2 plus ions in aqueous medium and get reduced to copper. Okay. When the switch is put on, the electrons move from zinc electrode to copper electrode, producing electric current. Electrons are flow from zinc electrode to copper electrode. As the electron flow from zinc electrode to copper electrode, the half cell equilibria keep on shifting from left to right according to Le-Chatelier's principle. As a result, zinc goes on dissolving, copper being deposited. The overall cell reaction when the cell being discharged. Okay, zinc goes on dissolving, copper get deposited. The overall cell reaction of Daniell cell, this is at anode and this is at cathode. This is the overall reaction. It is the overall reaction. As you know, EMF is measured by using potentiometer. Cell potential is measured by using voltmeter, which is connected in parallel as shown. The standard EMF of the Daniell cell is 1.1 volt. What's the EMF value of Daniell cell? The EMF value of Daniell cell is 1.1 volt. Okay. So, EMF is measured by potentiometer. Cell potential is measured by using voltmeter. Okay. So, when an external opposite potential is applied to Daniell cell, it continues as galvanic cell when the external potential value should be less than 1.1 voltage. Okay, already you know that was the cell potential value of Daniell cell. The cell potential value of Daniell cell is 1.1 voltage. If external opposite potential applied to Daniell cell, if it is less than 1.1 voltage, it functions as well as galvanic cell. The cell reaction attains equilibrium and the flow of electrons stops if the applied potential is equal to 1.1 voltage. If the applied potential value is equal to 1.1 voltage, it acts as what? Flow of electrons stops. The cell reactions get reversed. That is, electron flow from copper to zinc and the cell act as electrolytic cell when the applied potential is more than 1.1 voltage. If the applied opposite potential is greater than 1.1 voltage, the cell starts to work as electrolytic cell and flow of electrons not from zinc to copper, it get reversed, it will become copper to zinc. And cell potential or EMF of a galvanic cell is always positive. EMF of the cell as well as cell potential is always positive. When EMF of the cell was positive, then the cell reaction is spontaneous. If the EMF value is negative, the cell reaction is non-spontaneous. Electrode potential of electrodes are either positive or negative. Greater the value of cell potential, greater is the negative value of the free energy of the reaction. Okay. Next, what is salt bridge? Salt bridge is an inverted U-tube which is filled with containing non-reacting ions like K plus and Cl minus dissolved in agar-agar gel. Okay, it is an inverted U-tube as I shown in the diagram. Inverted U-tube filled with K plus and Cl minus ion in agar-agar gel. Salt bridge is essential to complete the circuit. To complete the circuit, salt bridge is required, allows ion migration between the two solutions of the half cells without the direct mixing of the solution. It minimizes the liquid junction potential. It maintains the electrical neutrality of the solution in both anode and cathode compartments by supplying anions and cations of the salt in the bridge two anode and cathode compartments respectively. To maintain electrical neutrality, in both anode and cathode, the compartment supplying anions and cations of the salt bridge to anode and cathode to maintain electrical neutrality. Okay. Sign convention. Anode is rich in electrode. The electrode is rich. Supplies them is called negative electrode or anode. It is rich in electrode. The electrode that is deficient in electron, receive them is called as positive electrode or it is called as cathode. Cell operates. Electrons are continuously generated at the anode, consumed to the cathode. Anode is a source of electron, act as negative electrode, whereas cathode for reduction act as positive electrode. Which is the source of electron? Anode, which acts as negative electrode. Which receives electron, that is cathode, which acts as what? Positive electrode. For symbolic representation of galvanic cell, in IUPAC rule, so how can you represent a cell? A negative electrode is written first, that is anode, followed by positive electrode. A single vertical line represent the interface between electrode and solution. If I put single vertical line, that represent the interface between electrode as well as what? Solution. A double vertical line written between anode and cathode representation that indicates salt bridge. That indicates what? Salt bridge. The double vertical line that is written between two anode and cathode, that represents what? Salt bridge. The molar concentration of the ions involved and partial pressure of the gas are given in parentheses. The symbolic representation of standard Daniell cell is zinc solid, single vertical line Zn2 plus aqua 1 molar, double vertical line Cu2 plus aqua 1 molar, single vertical line Cu. That is, this double vertical line represents salt bridge. The single vertical line represents the interface between electrode and its solution. The single vertical line represents the interface between electrode as well as its solution. This double vertical line represents what? Salt bridge. So the concentration of the solution written in the parenthesis. This is a symbolic representation of what? Standard Daniell cell. Next class, today class I completed with electrochemical cell or galvanic cell or voltaic cell. Next session I'll come up with how can you measure the electrode potential. How can you calculate electrode potential. So my dear student, today in this class I completed galvanic cell or voltaic cell as well as Daniell cell, electrode potential as well as standard electrode potential. Next session I'll come up with how can you calculate electrode potential. Until that, goodbye. Thank you. Have a nice day.